Assalamualaikum warahmatullahi wabarakatuh, and good evening to Dr. Amrala. So today me and my team are going to present about spectrum analyzer for instrumentation and measurement subject. So basically I will start with introduction first, which is what is spectrum analyzer. A spectrum analyzer measures the amplitude of an input signal versus frequency within the full frequency range of the instrument. The spectrum analyzer is to the frequency domain, whereas the oscilloscope is to the time domain. In the frequency domain, complex signals are separated into their frequency component, and the level at each frequency is displayed. Spectrum analyzer greatly reduce the amount of noise present in the measurement and also ensure there is no interference from neighborhood frequency. What's that is the difference between a spectrum analyzer and the oscilloscope itself. An oscilloscope gives amplitude versus V over S time display of a wave, whereas the spectrum analyzer display give amplitude B over S as frequency display. The oscilloscope gives distribution of energy in wave with respect to time, whereas the spectrum display frequency component of a wave and their amplitude. Well, there is most common spectrum analyzer measurements are modulations, distortion, and noise. There are two types of spectrum analyzer, which is wide-tuned spectrum analyzer. It's weight across the frequency range using all the frequency components present. This enables measurement to be made over a large dynamic range and wide frequency range. FFT-based spectrum analyzer. The FFT analyzer takes a time domain signal, digitize it using digital sampling, and then applies the mathematics required to convert it to the frequency domain. The result is displayed as a spectrum. So that's all for introduction and the types of spectrum analyzer. The next I will pass to my friend Fikri Yusuf, and the last part will be discussed by Khairul Azman Azmi. Thank you.
Okay, Assalamualaikum. My name is Muhammad Fikri bin Muhammad Yusof. My meeting number is 181049. Today I will present about the operation of spectrum analyzer for this assignment. Alright. The most common type of spectrum analyzer is a swept-tune receiver. It is the most widely accepted general purpose tool for frequency domain measurement and widely used super heterodyne. Alright. Okay. Very basically, this analyzer sweep across the frequency range of interest, displaying all the frequency component present. So the swept receiver technique enable frequency domain measurement to be made over a large dynamic range and a wide frequency range. Alright. They also have the input attenuator and mixer. The input attenuator and mixer is purposes is to adjust the level of the signal entering the mixer to its maximum level. Alright. If the signal level is too high, the readings fall outside the display, but also the mixer performance may not be optimum. So a mixer is a 3-port device that converts a signal from one frequency to another. Then they also have a gain, filter, and detector. IF stage provide the required level of gain, so it has to be used in conjunction with a RF gain control. If it too high a level of IF gain will increase the front end noise level, which may result in low level signals being masked. And then the IF filter is a band pass filter, which is used as the window for detecting the signal Its bandwidth is also called the resolution bandwidth of the analyzer and can be changed via the front panel of the analyzer. Alright, the analyzer must convert the IF signal to the baseband or video feed signal, so it can be digitalized and then view of the analyzer display. This is accomplished with an envelope detector whose video output is then digitalized with an analog to digital converter, which is ADC. Alright, and then they also have the video filter, LO, SD, and ADC. Alright, the video filter is a low pass filter that is located after the envelope detector detect and before the analog digital converter, ADC. So this filter determine the bandwidth of the video amplifier, and it is used to average or smooth the trace seen on the screen. Alright, the LO means the local oscillator. It must be capable of being tuned over a very wide range of frequency to enable the analyzer to scan over the required range. So the sweep generator actually tune the LO, which is local oscillator, so that its frequency change in a proportional to the ramp voltage. The video signal by the analog digital converter is also synchronized with the sweep generator to create the frequency domain on the x-axis. And for the last one of operation is a front panel, which is the three primary hard key on the any spectrum analyzer, which is frequency, amplitude, and the span. Other important control functions include setting the resolution bandwidth, sweep time, input attenuator, and video bandwidth. Most analyzers allow you to enter values by either punching in the value, which is push the button, or the number pad by dialing up or down to the desired value using the front panel knob. Alright, that's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Today I will explain about the advantages and disadvantages of the spectrum analyzer. So basically, any device have its pro and con. So spectrum analyzer has many advantages and its disadvantages. So for the first advantages is it is able to operate wide frequency range. So and then it has a wide bandwidth. And the third one, it is not expensive as other spectrum analyzer technology. So the disadvantages of this device is it cannot measure a phase and cannot measure the transient events. So there are many applications that can be applied by using this spectrum analyzer, such as it can study the radio frequency spectrum produced in microwave instruments. So basically in this microwave instruments, the horizontal axis display from 30 kHz up to the range of 2 to 3 of gigahertz. And the next, it can be used in the biomedical field, industrial instrumentation, and so on. So for the conclusion is, the spectrum analyzer measure the signal amplitude versus frequency. And then the most spectrum analyzer measurement are modulations, distortion, and noise. There are two types of analyzer which are swept tune spectrum analyzer and FFT based spectrum analyzer. FFT means fast Fourier transform. And then the next one is the major component in spectrum analyzer are the RF input attenuator, mixture, IF, which is mean intermediate frequency, again IF filter, detector, video filter, local oscillator, sweep generator, and LCD display. This device can operate over wide frequency range, and it is not expensive as other spectrum analyzer. It also cannot measure phase and transient events. So that's all from me. Thank you.